When the fact that both of those counts return the same number is not correct. I don't think. Well, it's not what we're trying to get.
So it doesn't really errors out like syntax error.
No.
Okay.
Oh,
It
no,
will
I
run
copied
without
it
a
right.
problem. So
Yeah.
basically, what kind of error is that?
I think if anything, it's a would that be a non-equidistant?
This statement will result in a logical error. So it's quite possible for you to have a logical error while writing an SQL statement, because what it does, it just gives you the mapping between the two. It doesn't really give you a true count of the publisher ID as to how many publisher IDs are there. It doesn't really give you the true count of ISBN number. It just gives you the true count of the matching record. So that's why it gives you 14, or whatever number you get is the same number in both columns. Okay.
So
Yeah, go
I have
ahead.
a question about that. If there's if there was a book that magically didn't have a publisher ID, like it was null, then it would not return that row, and it
Exactly.
would be one less. Okay.
Mhm.
So like, because the default table has 14 books, so it'd be like 14 books, 13 publisher IDs.
Oh, no, it will just simply ignore that. It'll just,
Oh, okay.
yeah. It will only give you the same number for both of them, and that number will represent the where clause, the matching
Okay.
clause, right?
Oh yeah, it would. Okay.
So which join is this? The statement that I wrote on line 6.
I think that's the cross join, right?
That is a cross join. There are multiple ways of writing a cross join. That's one way to write a cross join that you see on line number 6. And this is another way to write the cross join, as they now have an official word, cross join, for the cross join.
Is there an and keyword you can use?
Nope.
Good to know.
Okay, everybody get to see that? So if you go back to Blackboard and you look under the course documents, the entity relationship diagram for the database that we are working with, in the customers table, do you think there are any two fields that may have similar data?
Similar as in related or similar as in
Like
identical?
identical. Not exactly identical, but some values in one column you'll be able to find in another column.
Maybe address? Like anything in the address, so like
No.
city, state?
Yeah, if it is matches, it'll match exactly. You know, I mean, like a full value in one column will be found as a full value in another column of the same table customers.
Right, like city and state. So state one, you can't really do much about that,
Well,
but
yeah, the city, state, address, they are separate. Like address is the actual 2600 West Street.
right.
And yeah, so no. How about you guys run an SQL, like select star from customers, YS, and see if you can figure out that way.
Let's give that a try. I can select the thing.
Referred and customer ID or customer number.
Referred and customer number. And,
Oh, okay.
right. So those are
That's
the
what you
two
mean.
entities that has similar data items. So what do you think that referred column is?
Sure, it's like the customer ID of whoever referred that customer.
Exactly. So that's what basically it represents. So in this kind of a situation, it's a very good candidate for what we call a self-join, where two columns of the same table will join with each other. And that's what we'll be looking at as to how you can join the table with itself. So first of all, what you need to understand is it is possible for you to create two copies of the same table in the memory. Two copies of the same table in the memory. How do you do that? Well, you do that by giving the same table two different alias names in the same select command. So if you give a different alias names to the same table, the database engine will create two separate copies uniquely identified by two separate aliases, and then you will be able to establish join between the two. So this kind of a situation is called the self-join. Okay, so when the table joins with itself. So if I type select, whatever it is, I'll type the rest of the details from customers YSC inner join customers YSR. So that's how it generates two separate copies of the same table, one with the C name and one with an R name. On. Now it's up to you that, let's say if you want from the C, you want to grab the referred column and you want to match it in the R with the customer number column. Is everybody following me so far?
Mm-hmm.
Okay.
Mhm.
Now we need to pick the fields that we want. So for example, I want to know from the R table, the first name, because that's the actual customer who referred the other customer. So this is the first name of the refer. And this is the last name of the refer. And this is the last name of the referred. So now I can see that Layla Smith referred Gianna and Perez and Smith Missia referred to Gwen, and Jake referred to Dom. And for a better output, I can say order by R dot last name. So here you go.
Is there a reason why we have 3 Laylas and only 1 Jake and Messiah?
Yeah, because Layla referred 3 people. So if you go to all these 3 people's records in the select star from customers YS. So let's say we go to Perez, right? Perez was referred to by 1003. Gianna was also referred by 1003. And Smith was also referred by 1003. And who is that 1003? That's Layla. That's why we, okay, that's why we have it 3 times, because that's why we have her 3 times. Because she referred 3 people. The others only referred 1 person. And the rest of the people didn't refer to anybody. So if there is some kind of a promotion running that will give some kind of a benefit or discount or something to the people who are referring other people, then you could use something like this to do that. Now in your books, turn to page 239, which is example number 17, and read page 239. Let me know when you guys are done reading that. Christian, you done too? Oh, okay, that's fine.
No, I am.
Okay. Next, what I would like you guys to do is go back to this page on Blackboard and refresh it. This is where if you will find another script called textbook database. So all the examples in the book are based on a database as well, but I made some changes to the table name in the book. The reason I did that, because again, for the same reason, because these names are so generic, I did not want you to override any of the existing names that you have. So that's why I changed the names. So first of all, go ahead and download the script, and then you will open it. So this is what the script will look like when you open it. I changed the name of the customers to customers final, orders to orders final. So all the tables in the book, I just added the word final after their names. There were two reasons of doing that. Number one reason was to differentiate it from the existing tables so that you do not end up overwriting any of the existing table. The second reason was that you will be using this database for your final exam problems. So that's why I called all of them the word final. So you wouldn't have to create those or run that script during the final exam. That script would already be created for you. So go ahead and run the drops first. And again, you would have to do this on the V2 Cloud. So make sure you download this on the V2 Cloud, open it in the V2 Cloud, and then run the drops, and then run all these to create the entire database for you. So let me clear your feedbacks. So whenever you guys are done creating this database, let me know. Oh, I see. Oh, somebody else joined us too. Thomas.
Yeah,
Hello. Did you just join?
no, I got the gist of it. Just download the new or the updated textbook database and run it. Yeah.
Oh, okay. I didn't see when you joined. Okay, cool.
I missed
Well-
it, but is this an update or is this a total replace or a new?
This is a new database. Well, this database is the one that is used by the author in the book.
Yeah, but I mean, when I run the script, is it going to replace the existing one I have, or is it going to create a new database?
Well, that's it will create new tables. That's why I named them so unique that you probably will not have those tables. But still, I want everybody to run the drops. Maybe if you have any existing tables with those names that are dropped first, but the likelihood is that you won't have any of these names already.
I'm trying to run the script, but it's giving me an error.
Well, the other thing you had to replace was did you replace all the occurrences of Yusuf S with your ID?
Oh, sorry. Yeah, I have to do that.
So that's one more thing that you would have to go to edit, find and replace Yusuf S with ITPA, whatever your ID is.
Well, some of the references didn't go through. Weren't changed, is what I mean. On lines, the lines where you're adding the constraints to the tables, right there. Line up 111, for example.
Oh, because it should be employees final. Thank you.
Yeah.
Yeah. And it should be jobs final.
Same thing happens later on too.
Okay.
Lines, I think. Let's try it. Let's try again. All right, yeah, I just changed that and made it to the end.
Okay, the rest of the script is good. Okay. Let me fix that then on Blackboard. So once it's done successfully for you guys, give me a green check. So Oscar and Cameron got it. Okay. Okay. Thomas got it. Okay. Christina got it. Okay. And Christian also got it. Okay. Guys, just to test this, let's go to example number 1 in chapter 8, which is about the joins, the inner join. And remember, whatever table names are in the book, you add the word final after that, right? That's the only thing you got to remember. So test example number 1 from page 218. The very first example in chapter number 8.
The one with all the join types? Am I getting mixed up?
The example number 1 is the inner join.
Example
1 in chapter number 8. It is right after, it is figure 8-3.
8-3, okay.
Right.
My page numbers aren't.
Yeah,
not
yeah,
correct.
yes.
Forgot that my what is it, like the default name of the like table namespace, I guess you could call it.
Mm-hmm.
For me, it's not. Oh, and I forgot to change that. For me, it's not. It's not my IDPA number. It's IDPA number sequel.
Hmm.
So like, instead of IDPA 514 for me, I have to do IDPA 514 sequel dot whatever the table.
Oh, okay, 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 okay,
So I'm just deleting the existing table and just shoving it in
okay,
the
okay,
sequel one.
okay,
I don't have to deal with that.
okay.
Glad it's from a template.
The rest of you, Oscar, Christina, Cameron, and Thomas, did you guys get to run this example one?
I had the same problem as Christian, so I'm gonna be create the tables.
Okay, okay. Why is that? Do you guys have like a different, like a profile setting or something?
Not sure.
Okay. Hmm. Okay, everybody get to work. Get this working now. Okay. Likewise, I want you guys to try all the examples till 17.
Till 8:17.
Yes, till 17, which would be, because you need to know the figure numbers, right? Till figure 826.
Oh, try every single one until there.
Yes.
Ooh.
So there are, I mean, like there are only 16 more examples, but there are some other figures in between too, which are not SQL statements.
Oh, true.
Just so that you guys are also familiar with this database, because we will now be working on queries on both databases, the books database, as well as this textbooks database, as well as the one that we were working with before. That way you get exposed to multiple data sets. So I will clear the feedback, and then when you guys are done with your examples, I know I'm going to take you half hour or so. Let me know. So as we transition to the set operators allow you to work with two data sets, and you can apply the set operators on those two data sets. So the very first set operator I want to work with is a union operator. So what basically the union operator does, given the two data sets, it will combine them, but will not include duplicates. If you want the duplicates to also be included, you will use union all. So that's what union versus union all does. So for example, if I go back to my where's that? Course documents here. Course documents and here. Okay. In this entity relationship diagram, if you look at the customers table and the orders YS table, is there a common field between the two tables? Between customers YS and orders YS?
There's customer number.
Customer number, okay. So there is a possibility that customer number will be here multiple times in the orders table, but may only appear only once in the customers table. So if I were, oops, where'd that go? If I were to select customer number from customers, so let's see how many records I'm able to pull customers YS. That, oops. Okay, so I have 20 records that came out of customers YS table. And if I were to select the customer number from orders YS, I have 21 rows, including the repeating customer number, because there may be customer numbers that have placed multiple orders. Okay, let's do that. Order by customer number. Okay. So we can see that 1001, 1003, 1005, 1007, they have, or 1020 or 1018, they have placed multiple orders. So I do have some customers with repeated orders. So if I have these two tables and I union them, make sure you remove the semicolon at the end of the first query when you're unioning the two. You will get the 20 rows. The 20 rows are those that are not repeating. So every matching one is only picked once. And all the other non-matching ones are also picked once. So it's not really like an equi-join where it only picks a matching one. So among the matching and non-matching one in the union, it picks everybody only once. Now, let's do the union all. And in the union all, you will get 41 rows. And why is that? Because it picks all the records of customers YS, which is 20, and all the records of orders YS, which is 21. And 20 plus 21 is 41. So the first one will list all the customers. And the second one will list all the customers however many times they appear. Now, let's try the intersect. Intersect only brought in 14 rows. What do you think the intersect is doing then?
Only grabbing in rows or the data matches.
Yep. So it selects list of all the customer IDs that are found. Okay. List all customer IDs that are found in both tables or are common, avoiding duplicates. So in other words, this is the list of customers who have placed orders. List of customers who have placed orders. That's what these are. Now, let's try another operator. It's called the minus operator. One second. Oh, no. It's in DB2, it's called except, not minus. My bad. It's except. Yeah. It should be except. It's also called minus in other databases. I just got carried away. So except operator. So it lists all customer IDs that are not found in both tables. So in other words, these are the people that have not placed orders. In other words, these are the people who have not placed orders. So how many set operators do we have in total?
I mean, 3 or 4, depending on if you count union all as a separate one.
Okay, in your book, do example 18 and 19, and also read pages 240 through 243. read pages 240 through 243 and do examples 18 and 19, which is figure 828 and 829. Okay, so everybody was able to complete this. Now I would like you to turn your attention to page number 244, which is figure 830. In this figure, the author has used a where clause between the two unions. So notice in the very first example, he's pulling out the employee ID, the first name and the last name for all employees who worked in the department code MA. That's one set. The other set has all the retired employees who retired after 2011. See that? Okay. So now, what do you think the result of this union will be?
I think it'll just be anything within anything that matches both of those. So like so any employees in Massachusetts along with the retired employees that retired
So,
older or newer than that date.
can we say that it will give us the list of the retired employees who worked in the MA department and retired after May 1st, 2011?
Yeah.
Okay. So that's why we have to make sure whenever we are doing union between the two tables, that we select those fields only that are found in both tables. That's one rule to follow. So employee ID, first name, last name are found in both tables. So it creates a set of employee ID, first name, last name for all those people who work or worked in department code MA. Then it creates another set of all those people who retired after May 1st, 2011. And then between the two sets, it does the union to see the matching people, and only the matching people are displayed. Will it also display the non-matching people?
Shouldn't.
Union does.
Oh, wait.
Union should display the
A union
matching.
would,
Yes, the
but
union
intersect wouldn't.
wouldn't, right? So this is a union. So it will display all people who are working in MA department and all people who retired after May 1st, 2011. And the people who retired after the May 1st, 2011 may or may not have been working for the department code MA. If they work for the department code MA, they will only be picked once from the two sets. If they did not work for the department code MA, they will still be picked because they're part of the other set. So do this example.
Doing figure 830, right?
Yes.
Okay.
Yes. Okay, now let's turn to page 246, where joining several tables comes into place. And this is example number 21, figure 831. This is where we are picking the customer name and we are picking a field that we are calling, aliasing as discount % from the customers table. And this is where we are rounding it to 2 decimal places. And then we are unioning it with the customer name and the discount from archived customers. So it returns the customer name and discount % columns from the union between the customers and the archived customer table. As a result, as you can see in the output that gets pulled, we see the customers only selected once from both sets, such that for each customer, we get to see the customer and the discount %. Archived or non-archived, doesn't matter. So do this query, which is figure 831. So that should be customers final and archived underscore customers final, those 2 tables. Okay. Well, I don't know if this is everybody done, or I think this was from before. Oh. Okay. Christian, still working on it? Figure 831.
I always forget.
Okay, okay. Guys, let's take a break here till 10:15. And then when we come back, we'll look at more stuff.